In order to automate, you need to learn Python or another programming language. Please raise your hand. Don't be shy. It's quite a good number. And today, I will do my best to prove that for the next few steps, for the very beginning, when you start automating, you don't need. All you need is the following: some basic system ops, some networking, of course, and some basic YAML and Jinja understanding. That's all you need. In YAML, you need 3 rules. You need to know about the column, you need to know about indentation, and about the dash rule. You have here a link, you can click on it, and you can see the documentation for understanding these rules. It's right over here. It says about indentation, columns, and dashes. The second one is about Jinja. We need to know about the double curly brackets to replace variables with text, about if, elif, else conditional statements, and for loops. That's all you need for the beginning. In this tutorial, firstly, we'll see the tools we'll need. We'll see how to install them, how to set up your Vagrant environment, but this is for demo only. Please don't do this and claim you're doing automation on VMs. Automation is for real networks. Configure Sol stack. We'll see then how is the CLI syntax. Then will be introduced a bit in the configuration management part. And at the end, we'll see some advanced topics very briefly, but I will point to documentation and you can continue reading afterwards. For the live setup, you can have access to a remote server, or you can have a Vagrant with a couple of VMs from your favorite vendors. I will be connected remotely to some AWS instances, so if you can do something similar, that's great. Otherwise, if you can't do any of them, no problem, because in this tutorial mostly I will just copy-paste from the slides to my CLI. So this tutorial should be enough for anyone just following the slides to set up your environment. First thing, why Salt? It's because it's very scalable, not only for us. We manage a couple of thousands of servers using Sol stack, but if we look elsewhere, at LinkedIn, for example, they manage 70,000 servers with Sol stack. Is there any doubt that it's not scalable enough? Also, concurrency. Everything is parallel in Salt. You can access the resources of the network independently, or as, for example, in our case, network engineers are distributed across the world, and they can access the resources and run commands independently, no matter how many, and you will see that in Salt everything is parallel. No matter how many devices you handle, the speed is the same. You have one device or 1,000, it's the same speed. It's very easy to be configured and customized and to extend. It has a configuration, verification, and enforcement logic. It helps you to periodically collect statistics and cache some other things like LLDP neighbors. You can cache them and access them instantly whenever you need them. And also has many built-in drivers that other people wrote them and you only need to use. You need to understand also the difference between orchestration and automation. What people done in the past was just automation. They had a command that was deploying some automation, meaning that they had a template, they was rendered, loaded on the device, and that's the automation everyone talks about. But is this enough? For example, you need to apply some changes depending on events. Like one of your BGP neighbors goes down, and what do you do then? You go and type manually that command, so we basically just replaced one manual task with different manual tasks. And here comes the orchestration. With orchestration, you can instruct your system, that to react on certain events. So the system will know, oh, your BGP session went down now. I will go myself and I will apply the necessary changes to fix that. And you can stay on your beach and enjoy your cocktail. Also, the speed of salt is something that everyone noticed at a glance. It was designed to be like that. And salt is an orchestrator, plus has capabilities for configuration management, event reactors, has support for cloud providers, and all built around the salt high-speed communication bus. And from the latest major release, it has also cross-vendor network automation from because it has embedded one library we'll see later. It's called Napalm. This Napalm is basically just a wrapper of different sub-libraries that allow you to connect and manage devices like Juniper, Cisco XR, Cisco Nexus, Fortinet Arista, MikroTik, and many others. We have mixed them together, and since the latest release of Salt, Napalm is integrated and comes with many facilities to allow you to handle the configuration, but not limited to. How to install the tools? We'll do it together, if you can. Just to see how many people would like to do it together with me. Okay. For the installation of Napalm, you can click on this link and we'll point you to this page where you can see the dependencies that need to be installed. Also, from the I will install only one of the sub-libraries of Napalm for handling the Juno S, and I will install the dependencies like that. As I said, I will just copy-paste, so you should be able to replicate the same. I'm using a Debian server, and I will connect to two VMX instances. So this is why I am going to install Napalm GNOS. Now, I need to install also PIP. Who doesn't know about PIP is a package manager to install libraries that are not packed for different operating systems. And now, using the PIP, you can do PIP install Napalm-GNOS. It's going to take a while to have all the things set up. The second part to be installed is SaltStack. Again, you have only a couple of things to do, is to install the SaltMaster and the SaltProxy. If you click on the complete installation notes, it will go, you will go to a page, like depending on the platform you want to run. As I'm running on Debian, I'm following these notes, and again I will install firstly the repositories to take the backports. Okay, because I need sudo. And then the other thing, you can click on this link and will bring you to this page where you need again to follow the steps to accept the keys from the official repository of SaltStack. Again, I will add this line into the file specified here. creates the repositories. Now apt-get install salt master. Why it's important to be from the SaltStack repositories is to get the latest release. Latest release being 2016.11.2. There are quite a few dependencies to be installed. We only need to wait. About Salt, you need to know that it works, the architecture is hub and spoke. So the hub being a Salt master, usually it's a server that is running this instance of Salt master, and the spokes are, it's called Salt minions. Usually the minions are instances running a different software package called Salt minion. But as we know very well, on network devices, you can't install open software or any kind of software in general. So they come with this idea of a proxy. A proxy basically emulates the behavior of a normal minion, but is running on a different machine, and you connect remotely. Proxy is not, for who knows Puppet, do not confuse, is not a separate machine. A proxy is just a separate process. It's forked on the machine you want to run. And okay, all set up. And you have one process, one proxy process per device. So if you have 100 devices, you have 100 processes like that. Now, a second, because it needs some libraries to compile. This is the most boring part. We all need to go through this. I preferred to do it together to see what are the necessary steps. I have, if you don't want to wait, we can jump directly. I have a different machine that has all this environment, but I think it's more important for you to see all the steps. Meanwhile, who wants to use Vagrant? Do we have any Vagrant users? Anyone? Okay. As this assumes you have a Vagrant and VirtualBox already installed, you need VirtualBox at most 5.0, otherwise Vagrant doesn't like it. And I have two examples of Vagrant files. You only need to place them in your home directory, for example, and you just need to do afterwards, after you download the boxes, you do Vagrant box add and add your boxes, or Vagrant up, and will know that based on the Vagrant file to identify what box you want to run. While this finishes, if it finished, and can do from a Python shell, can test, import napalm _Juno_s. And it doesn't throw any error, so your environment is set up now. For who wants to see the Vagrant part, I have this Vagrant file, which is says this vsrx point it to this vagrant box Juniper slash FFP and so on. If you do vagrant box list, it says this box does not exist. So if you go back and add it, we'll start downloading it. It's automatically downloaded from the HashiCorp. You need to say if you need the provider to VirtualBox or VMware. To download it, but I will stop it. You can do this, and then when you do vagrant box list, will show you here. Show you here exactly this name. Similarly, with the EOS, which you download from the Arista software download. You download it, and it will be shown like that. And you import with vagrant box add, then the name of the box, and dash name to add a custom name eventually. After you add it, you can start it directly. You say vagrant box, vagrant app EOS. Do we need to wait for someone? Okay, can move on. Now, for who's new to Salt, you need to know, to learn about two entities. About pillar is a free-form data that can be used to organize configuration values or manage sensitive data, like interface details, NTPPS, BGP config, and so on. Most of the time, these kind of entities are written by the user. Generally, is one file per device, but can have other files that can be included in others, or can have one file that can be used by many devices, as we will see later. But generally, is one file per device. The grains is data collected from the device, like a device model, vendor, uptime, serial number, and so on. You don't need to do anything about this. Salt does it for you, but you need to understand what is this grains, because we'll reference this later. Now, the master config file is usually in /etc salt master. Depends also on your platform. On Debian, by default, will be on /etc /salt. On CentOS, I think is on /srv and so on. There are many options to be configured at this level. The most important are the file roots and the pillar roots. Under the file roots is the place where you will store from now on your state files and reactors and all the action part you will need. Don't worry if you don't understand what is yet a state and a reactor, but it's good to keep in mind that to have this link between file roots and states, reactors, and so on. The pillar roots is the place where you will place your pillars we have talked about earlier. Also, you can define different environments like base and or production and QA and develop. There are many other options, but for the moment, let's focus on this and keep them in mind. And so I will go now under /etc /salt. Oop. The master config already exists because it's installed, is configured by default when you install. I need to do something else before. I need to install my favorite editor. Okay, now I can do a search for file root. And we can do file root base. This master config file is YAML formatted, salt and states, let's say. But I will also add a couple of salt reactors, also etc salt templates, from where we'll keep our Jinja templates. Salt, and that's it for a moment. Okay, and the other one, pillar roots. And again, the environment name is the base one. Will be placed in etc salt pillar. Now the salt master is already running. You do. You'll see that there are a couple of processes running. Also, you'll see the salt minion. We won't need it, so we can stop it with systemctl. Okay, as the top file has been, the master config file has been changed, we need to restart the master. The second part is the proxy config file. It's again a file with many options. The most important being this one. Just pay attention to the multiprocessing. This is very, very important because, as I said, each proxy runs in a separate process. And because all of them are running on the same machine, or it can be also on a different one, we are running SSH-based proxies, and to avoid spawning one new process per command. This requires also some deeper understanding of the core of Salt. For the moment, you just pay attention to be like that. Okay. Now we need to create one pillar per device. We go. We make the directory of the pillar, go under this directory, and device1.sls. The extension of the file is .sls. SLS meaning salt stack, and is YAML plus Jinja in the same time. You need to place this content where we have the proxy type, which has to be napalm. Then the driver name. You depending on what you want to on your machine, you can choose between GNOS, EOS, IS, and you can see the complete list at the napalm official documentation. I'll paste this and I'll update it. Host. I will take the host from here. And the password Nepal 1, 2, 3. Similarly, I can copy and create this the other pillar. And link to the other machine. Now, you need to know also about a different file called the top file. In this file, you will say, you will identify or make the mapping between the minion as ID, and the minion ID is for how you will identify your devices from now on. For example, device 1, and what pillar file is to be included for these minions. Can be a couple or just one. And I will simply copy paste this base and this top file, and again you can identify the environment name depending on how you have defined them in pillar roots and file roots. Pay attention to not include the .sls extension. Here is the file to be included. We have defined those two files, device 1 and device 2, and when you include them, you include only the name of the file. Okay, that is not correctly formatted. All good. The master systemd file comes by default. If you don't have it on your operating system, you can add it, but is optional. It only helps you handle the process much easier. Similarly with the proxy one, which the default one, I don't really like it, so I will replace it. This, it only says the process is identified with salt proxy at, will execute this command, user bin salt proxy and proxy ID. How to start the salt master? We've already done something, we have restarted. And now how to start the proxies. Like that, and like that, using the, and this uses the systemd file, because the systemd file, it was called like that, salt proxy at. If you don't have the systemd, you will need to do it manually, and to not forget about this option, -d, to start them in daemon mode. When you start, because of security reasons, all the proxies, all the keys will be denied. So you can do salt key -a to accept the key of the minion, and similarly with the other one. If you don't want to be asked, you can put the -y at the end, and will accept it. And now, if you can do salt device star. This one connected, and we are connected and set. And that's all. That's all you need to do to have your environment set up. Did we write any line of code so far? Now to introduce you in the salt CLI syntax. It begins with salt. I've already done it already. And then you specify the target. And the target can be simply the minion ID plus many other options. You can use the grains we have talked about earlier. I will show you immediately some examples. Or you can make regular expressions. For example, we have a list of devices, device 1, 2, and so. We can put, for example, I will do it right now, device star, and we'll reply both device 1 and device 2, because this star matches everything. Now for each device, you can see its grains.items. And those are the grains. It says it has this serial number, this uptime, this is the vendor, this is the version, and the operating system is GNOS, the model is VMX. And this is for all the minions. How to use these grains? I have here a couple of examples. The star, we have already seen it. You can do salt edge net.traceroute and will execute traceroute on all your edge routers. Or you can define something more interesting, something called node group. You can read the documentation on the link here, which you can define a list of devices or minions that are within a group. For example, we have this node group called NA for North America, and you can target all devices we have in North America just like that, salt-n NA. Or you can use the grains. And we'll do it just right now, -g, and says OS, because the OS is this grain here. And then what grain? GNOS. And oh, there. Net.arp. And we'll return you the ARP tables from all devices that run GNOS. I don't have any IXSR or anything else, so all the time for me will reply with all minions I have set up. But for XR, for example, you would do IOSXR or EOS for Arista or NXOS and so on. Other things you can do, you can match this one with this one together. It's called a compound matcher, and you can select all devices that whose ID begins with something, plus you can say, give me the grain, which one? This OS, that has this value. Also, you can use other grain together, and you use the AND. This example, for example, it gives you the ARP tables from all devices whose ID begins with Edge, running IOXR 602. Another grain example, you can extract or the results of all RPM probes from all Juniper MX480 devices. An example we've just seen, I will do it for one single device. For one single device, and is displayed nicely and colorful like that. This output format is called nested. You can display your data in many other shapes, like only doing out equals JSON, and will return you a JSON format, or YAML, and returns you data formatted in YAML. Also, you may have noticed the speed, and if you are doing on all devices, you can see it's exactly the same speed. Exactly the same speed will be if you run it on 1,000 devices, 10,000, and so on. We've seen these outputters, and let's introduce ourselves a little bit into configuration management. We'll go steady, we'll go with some dumb examples, but you will see how they are useful, and little by little how to build something. For the beginning, we'll load some static config. So device 1 net.load config, and then is the text. For GNOS and for all libraries supported by Napalm, the format of the config is text. So for Juniper, the text is that one with curly brackets. So for example, I will update I don't know, system NTP peer. I will do it firstly a dry run. That test equals true, can you see it? Here at the bottom says test equals true. It's not displayed very nice here, but I'm not sure what I can do about that. Test equals true is necessary to run a dry run. What it's going to do, we'll apply the config, we'll do a load merge logic, we'll get back the diff, we'll discard the config, and we'll return. And it says that configuration has been discarded. It displays you the diff, how it's returned on the device. It's exactly how would you do on the CLI show pipe compare. It says the result is true, nothing failed. And also it says already configured, it points is a flag, a Boolean flag telling you if it had anything to change. If we strip that test equals true, we'll go and we'll commit. We've seen already the dry run. If you need to load more changes, you can put them in a file and specify the absolute path to that file. Now will take a bit longer because this is how it takes the commit on this VMX. In this case, there's nothing we can do about, unfortunately, only to ask Juniper to speed up their boxes. So, been waiting. Sure. Unfortunately, Napalm does not support yet set format, only text. I'm trying to introduce, but it's a bit of pushback. Come on. Okay. But you load static changes, it's fun, but it's not very helpful. But instead, you can we start looking at templating. This command is called now net.loadTemplate. Then you specify a name for your how will be identified in the logs. For the moment, we'll see something that again is not for production, is for exemplification. You have inline templating, and you replace your variable with this host name. Between the double curly brackets will be replaced with this text. Okay, this one it took too long, and this is how it looks the error when it is not able to commit. I won't try again, but instead I will run the other one, net.load template, set host name, and now I will do this inline templating. Template source equals system host name, and then the name of your host name. This close one curly bracket, and host name equals stuff. I will run a dry run again, and as we have expected, it will come back and will say, I will replace your actual host name with the new one. You can use the grains inside the templates. That is something very special of Salt. You will do something now, like grains dot. And this is how we can access them. Grains dot name of your grain. We'll do like .os followed by .grains. I don't know, what would you want? Cereal. We don't need this variable anymore, and we run it. And it says you will have this hostname, junos dot serial number, because this is how it's represented here. Grains.os, grains.serial. And this is how we can use in all the templates the grains. Using those grains, you can identify the vendor of the device you are running against. And this is how we can define cross-templating, cross-vendor templating. I will have this example. I will just copy-paste it in what it says. It says if it's a Juniper device, apply this configuration part. If it's Cisco or Arista, apply this one. So it's already much simpler, if you have a multi-vendor network, to identify I am running against a Juniper, or I am running against a Cisco or Arista, all in one single template. Of course, you can split it out in multiple templates and include them. This is the best practice. And now I will run the previous command, specifying, this is home admin, specifying the absolute path to your template. Example test equals true. And indeed, it's done, and it took this variable from the pillar, because this is how we said we take the host name from the pillar, and this way we have introduced a new way of taking data. You take it directly from the pillar. You look under the proxy, because if you remember, the pillar was structured like proxy, and then underneath you had host name, password, and so on. using the grains, you have identified, is it a juniper? And he said, yes, it's a juniper, and has applied this part from here. If you'd run exactly the same template against Cisco or Arista, it will know that what part to be run. I run it in different instances. I run it again Arista and Juniper, and one single template you need, and you have all in there. It's much easier to identify if it's Juniper, Cisco, and so on. What is also very important, there's one more option in the CLI, debug, and is again a flag. You put it as true, and it will show you what has been rendered, because what the template generated is not necessarily what is the diff. Is generated this template where I have many white spaces, but the diff is this one. You can generate something. Your template can generate something, but the diff can be empty because maybe it was already configured like that. And in this case, this flag will tell you that it's true, it is already configured. Now, the right way to specify your template source is using salt column // This is automatically translated to file roots. If you remember in the master file, we have specified that file roots. Is the place where you can put templates. If we go now and etc salt templates, salt, and I'll create the directory. And I'll copy home admin example. I'll copy it here. And running exactly the same template, but now using salt --. And we'll know automatically where to look for this template, because it has been specified already in the file roots. Why is this important? Is because let's suppose you can move your entire environment. You don't want to depend on a particular machine to have absolute path. You can specify it just like that, salt, and you can use afterwards when you move on a different platform exactly the same. You don't need, you will not need to change anything else. It will be directly indexed by salt. Moreover, you can have templates rendered from a different source, from elsewhere. You can have rendered them from HTTP or FTP, from version control directly from your Git server or cloud providers and so on. This example is for iOS. Let's do it together for GNOS, because this is what we run today. Go to GNOS templates, and we'll have set NTP peers. We take this one, and as we have run salt --/ we run exactly with this one, where you also need to specify the peers variable. And I will do it again in test mode, and I'll show also the debug mode. And it rendered a remote template. It rendered a template that is not on our machine, is directly taken from GitHub. And you can do exactly the same with any of the available options. I will go back a bit about this debug mode. This is very important because who has previous experience with Jinja is pretty painful to debug. Salt provides a couple of options to help you debug. This one is one of them, and it shows you the result of the template after it was rendered. But also, in case your template fails, you can check that using the embedded debug tools. This one is one of them, show full context, and shows you all possible variables in your template. And also, you can have logs inside your Jinja. You can do salt.log.error, and will log an error on your minion log. Okay. What another characteristic of Salt is that you can reuse data inside the template. You can, as we called earlier, net.arp gave us the ARP table, right? Inside the template, you can do salt.net.arp, and you can use it directly. You don't need to export data elsewhere to re-import it back in the system. It is already there. You only need to call it like that. So I'm going to just copy. This is the template. It's exactly the same. So I do it arp.jinja. And what does this template do? It retrieves the all ARP table from the device, and it looks, again, is a cross vendor, and it says if it's iOS XR, I'm going to apply this chunk of config. If it's a Juniper, I'm going to apply this one. The point of this example is not to be used again in production. It will take the ARP table and will cache it in the config. We'll take the ARP table and we'll write config lines. Definitely you don't want to do this in production, but it's to show you how you can reintroduce data back in the system. And I run earlier this example.jinja. Now I'm running this one. And it says it has generated this config based on the ARP table and would generate this diff. It has discarded. And as you can see, this is exactly the data we had in the ARP tables. And I think this is a very good example and very useful about how to reuse data rather than writing modules that basically do nothing else than exporting, re-importing. I have another example of advanced templating. This one retrieves the properties of the default static root, and if it's not there, it's going to add it. If it is, it won't generate anything. Before going on, let's see what this command does. Root show 0, 0, 0, 0. It gives you back the static root on from this device. We have already, and now when we are going to run this state, guess what is going to happen? It says load the config, nothing. Why? Because the static root is already installed. So I'm going to make a change, and I will update, and will retrieve a different static root, like 1.0, 1.0.0/0. Doesn't necessarily need to be to make sense. This again a configuration discarded. Okay. On a different device like iOS XR, this one would look similar, but different config diff. Now, who wants to play a bit with this of re-importing the data back in the system? You can use this advanced templating feature for many other things, like you only need to write like 10 lines, and you can export your details from the interfaces in a Postgres database. You can use the bgp.neighbors to remove the BGP config from your BGP configuration neighbors in active state. How you can see this is again a different command, bgp.neighbors. I don't have any neighbors enabled. Other ntp.peers, and it shows the list of peers configured on device. ntp.stats, it shows you the synchronization of the NTP on this device. Other commands I didn't expand it about is the net.interfaces. And we'll retrieve the interfaces details from this device. This is only the operational details, not configuration. It retrieves the MAC addresses, if the interface is enabled, if it's up, when it flapped last time, speed in megabits per second. For some interfaces like this one, you don't have such details, but for others, you have like FXP or so on. To see the IP addresses, you have this command net.ip address, and will show or display you all these details for each interface, IPv4 and also IPv6, and their prefix length. The list of examples can be nearly infinite. You can also remove unsynchronized NTP peers using the ntp.stats we just seen. And again, remind you, inside the template you do salt.ntp.stats, ntp.environment to push, for example, high temperature notification in Slack, and so on. You have thousands of functions to be used inside your templates. Here's the long list. There are many modules you can use. It depends on your needs, what you want to do. You can manipulate databases, chat ops, and so on. The examples I have exposed earlier can be achieved in a much elegant way using some of the advanced topics like states, or you can mix them with reactors and so on. For this, I will point the documentation where you have to read. It's a lot of documentation you have to look at, but they will help you a lot. We'll see earlier how to use the orchestration capabilities of Salt. For example, when a BGP neighbor goes down, it triggers a BGP configuration change. You don't need to go and manually type something, run this descriptor. When a git pull request is merged, it triggers a configuration update, for example, on all your routers. High temperature alerts, notifications in a Slack channel, chat ops, and many other examples. About states. State is a kind of module that makes sure that what you have in your pillar, where you store these entities of data, it makes sure that what you have there is exactly the same as on the device. What is not in the pillar will be removed from your config. What is in the pillar but is not on the config will be added. In the latest release, we have introduced a couple of states like netNTP for NTP, netSNMP, users, probes for IPSLA and RPM probes. And this one, netconfig, will be introduced only the next release. This one will help you run and write any kind of configuration changes you need. Is the most generic and the most complete state of all. And we'll begin with something trivial. We'll see how you use the states to update NTP peers. In a separate pillar, like ntp_config, we'll put this content. So we'll go, ntp_config.sls, paste this. It's again wrong formatted, so we need to make sure that is correctly added. I think I need to add so 17.17.2. And this entity of data does not depend at all on your vendors. This is cross-vendor. You work only with entities of data. You don't work, I want these NTP peers and it has to look like that on Cisco or Juniper. It doesn't matter. They all look the same. And it's quite natural. ntp.peers and follows a list of peers. ntp.servers, a list of servers. Okay, let's go back here. Then you can include this file in your device. You can say include, and you point to this file we have just defined. If you want to be more generic, you can update the top file. As I said, in the top file, you specify what files to be included per minion. If you want a file to be included in all minions, you do star, and then you say, I want NTP config to be updated, to be included in all minions. And then you need to refresh on the pillar detail. Refresh. Okay, in the refreshed, and now if you do a different command, pillar.show pillar device 1, it says this is what you have in the pillar. It has included and merged what you have manually defined earlier, plus what you have included in all files. If you go back, look in here, you have in this file, device 1, the descriptor, only this. But it also adds all the other information you have specified. Then you need to go under the states directory and add the descriptor. This is in state SLS descriptor. It simply says, take this entity, ntp.peers from the pillar, and ntp.servers again from the pillar, and send them as parameters for this state, net.ntp. If you go to the documentation, it says that managed, this function, net.ntp.managed, takes as variables the peers and the servers. So I'm going to just copy paste this, and I will go in the states. States. One another detail is this pipe JSON that is not mandatory, but is one of the good practices to not rely on the default serializer of Python. You sometimes can create some differences. You may want to use this filter to serialize explicitly the objects. Yeah. Okay. Now you need to include under your states, you need to define a file called init.sls, where you include the file we have just defined. .sls. Which says that in this init, you need to include this file, ntp.sls, again, without the .sls extension. And now you can run the state. You only need to say router.ntp, because we have, this is how we create the directory. So I'm going to create it now. Move anything.sls into router. And now if you run device 1 SLS router.ntp, you can have again the dry run mode. And it says, I would add this NTP peers. I would remove this, and I will add this NTP servers. Again, you have worked only with entities of data. Did we route any line of code so far? Not yet. And again, you can commit these changes without, if you stripped again the test equals true. Now, if you want to make sure your config will be updated consistently, you can schedule this state to be executed at specific intervals of time. For example, you can say run this state every day, or and so on. Before going further, let's have a look at the SALT event system. SALT is event-driven, and everything that goes into SALT, it's recorded through an event bus. And each command you do and anything that happens has a unique job tag, like this one. If we go back to our instance and we run this salt run event state.event. Still waiting for the machine to commit. I'll stop this one because it takes a bit longer. I'll try on the other one. Okay, this is what we do on the device too. I will commit the state. And this is in the other tab. I have two tabs open here. It says those are all the events that happened. When you run something, it assigns a unique job ID that says you are running against these minions, device 2. The master queues this task and assigns this job /new because it's a new job. And this is the result returned by device 2. Similarly with the other job, because the first one was in the testing mode, the other one is going to commit. It takes a very long time right now on these boxes. Using these job tags, you can identify events. We have looked at these jobs. It has this unique tag. You can apply regular expressions and you say salt/job and then any job ID /new. You, when this happens, when this event occurs, go and run this reactor. Again, the reactor can be specified using the salt column // and will be relatively linked by salt, depending how you have specified the file routes. Inside the reactor, you can process and you can call different commands to be occurred when an event happens. For example, I will go on at a different entity called beacons. Beacons let you use the salt event system to monitor non-salt processes. I have this example with iNotify that will fire events on the event bus whenever you update a file, like this one, /etc salt pillar ntp config. Whenever a change on this file happens, it's going to fire an event on the event bus like this one, and which says that the configuration file has been changed, the file has been changed, and the minion ID is this one. So I'm going to look at the beacon iNotify documentation. And it says it has a dependency pynotify. I'm going to install the necessary tools. Okay, this one takes forever. And I'm going to install the iNotify tools firstly. And then with pip install py. It's called py. If we go to the, I'm going to add this beacon configuration in the proxy. So all the proxies will have this beacon. So whenever a change occurs on this config on this file, it will fire the event. So I will take it from here, and I will add it in the proxy. So this is how my proxy looks like now. It has all the configurations we had before, plus this configuration for the beacon. To take the new configuration, you need to restart them. Proxy at device 1 and device 2. The net.connected, it says only if the connection has been successful. So we're waiting now to establish the connection. Okay, true. And we have here the event bus recording. So I'm going to do in the pillar and update the NTP config. I will simply remove one line. And it fired this event. It says NTP_config has been changed, and it pushed one event. Okay, we can go one step further. Using the reactor system we have saw just earlier, you can identify all these jobs that have this ID. If we look here in the event, they have this ID, salt beacon, and then the device ID, I notify, and the path to the file. And adding these two lines in the master config file, it says whenever this event happens, or regular expressions, because salt beacon, and you don't want to depend on a particular device, you want to match all of them, go and run this reactor. This reactor will simply run the state we have earlier defined, the router.ntp, and will run it against the minion ID that triggered the event. So I'm going to add this into the master config file. But I'm going to apply a small change. And I will strip this /reactor, because I have created a directory reactor where I can input my reactors. If you don't create that directory and you don't have it under the file roots, you will need to specify the reactor, or wherever you have wherever you put your reactor file relative to the file roots. Need to restart. Salt master to take the new config, create the reactors, reactors, cut master. Because here is defined as reactors, I'm going to create the reactors. Under reactors, I go and I will simply paste this configuration chunk. This was set, but I need to specify this file name. Why this file name? Because this is how we have specified in the master config file. Go under reactors and run this reactors descriptor, which has this content. Okay. And now let's go back to the pillar. And while this event bus is still recording, I will update the NTP config file. Again, it triggered events. It triggered this event and this event, because the NTP config file has been changed, and the reactor system immediately kicked in and said, run router.ntp against device 2 and run actually state.sls using router.ntp, which is exactly what we have run earlier when we've done state.sls, router.ntp manually. But now this one is doing it by itself. And fortunately, this time the machine was kind enough to commit. And this is what happened in background. We didn't do absolutely anything. And you can do salt device 1 ntp.peers. Come on. And it has exactly what is under your file, ntp config. It has this ntp peer configured. If you do ntp.servers, it has only this server, exactly how you have defined it in the ntp config. And this is what happened behind. It says, I have changed, I have removed one of the peers. Oh, sorry about that. And also said that it has removed one of the servers. And you only have updated one single file. You want to do this again? Is this obvious enough what is going on? Just updating one file, it goes in the background and will apply the changes on all your devices. And basically that's it. From now on, if you want to update the NTP peers on all your devices, you manage on one single file, you add and you remove from that file, and the system will do it for you automatically. This is recommended to run in an environment where you have peer review. And if you set up your Git to follow the origin, when the pull request is merged, the file will be updated also on your server. And when the file is updated on a server, we'll kick in the reactor and we'll update the router's config. So you basically click one single button, merge the pull request, and you have your network up to date. Also, you can have embedded caching. You can cache some functions. The result of net.arp, for example, you can cache it. It doesn't change very often, and whenever you need it, you can access it instantly without retrieving the data, the live data from the device. You only need to say, cache me these functions. You say mine functions, and then the functions you want to be cached are those we have run a couple of times, net.interfaces, LLDP, ARP, or any other command you need. And then you specify how often to be refreshed this data. I will add this in my device pillar. And it needs to be, not necessarily. You can do device 1, mine.update. Okay, I need to restart actually. Wait a bit to come up. Not connected. And when this will reply, it will go and will start caching the output functions. Meanwhile, we can look at another topic, one of the advanced topics, about the Salt API. We can, using only three, maybe 4 lines of config you put in the master, you specify only the certificate details and eventually the port, otherwise we'll use the default port. You can set up your REST API and you can run the commands we have run on the server directly. You can run them remotely. And you have many consumers without necessarily being logged in on your server. It's only three lines of config, and you are all done. You only need to restart the salt master. There are many other advanced topics we can talk about. You can have these links, but I recommend you to go into this amount of details only when you understand perfectly what we have discussed about today. About orchestration, you can define very complex workflows. For example, you have an event that triggers an action, and you need then to go and apply many other actions, like update this list of interfaces. If you are able to update the list of interfaces, go and update also my BGP peers. Eventually, they may use that interfaces. If you are not able to update my interface config, stop here, and so on. If you are able to update the BGP config, go on and update anything else, and so on. This is very useful. This is real orchestration. This is a bit high level. You can also externalize events. Everything that goes through this event bus, you can externalize it, and you can have rich logs in Logstash, or you can push notifications in a heap chat channel. Again, with these are 2 or 3 lines of config you need to add in the minion mostly, or also in the master, and we'll do this automatically for you. Pillar. We have worked with the pillars that were statically defined on the server. Like we had device1.sls, device2.sls. But they can be also external. For example, you only need to say, use as a source of truth this database. And you specify only the host name and the port to connect to the database, and will retrieve dynamically the data from there. There are many drivers already done for you. You only need to say, I want this to be a Postgres, use it. All the minions are able to authenticate. We've done at the beginning, when after we set up, we've done this. We have accepted the key, we've done it manually. But I have here a note, this accepting the minion keys can be automated as well. Using the auth of type modules, I am referencing right here, this one. You can automate and accept the keys of some minions automatically. You don't need to type salt key -accept and so on. Other topic are the returners. We saw on the CLI you can put --out and will display your data in JSON, YAML, and any other format. But this is on the CLI, it is just visual. If you want your system to simply, when a command is executed, to forward the raw output in your in an external service, you can use these returners. And most of the time is just on the CLI is --return, and then can, for example, send an SMS, or it can be also included in this reactor. You can add, as we have in TGT, which is the target, arguments, you can have also ret. And whenever a configuration like that happens, based on the update of the file, it can send you an SMS or can update anything else. And this is how you are notified, hey, someone changed this file and I have deployed it worldwide. Quickly some example. This is how we watch our network improving by itself. We have started monitoring our carriers, and we have installed at the edge of our network many thousands of GNOS on RPM or IPSLA probes, depending on platform, GNOS or IO6R. How many? About 7,000. And the configuration of these probes has been generated with 4 functions only. We have already embedded in a Sol stack. Immediately after you install it, you have them. Without getting into details, this is what is called a runner. it generates this config. What happens behind is not important. It's important for the moment the process. And how are they deployed after is again from this pillar. This state file, it ingests this config. Similarly, as we had state.sls router.ntp, this one does the same with the probes. Again, using a state module that is embedded in a Sol stack, and you can use it and generate something similar. And we have many thousands of probes worldwide, continuously monitoring the backbone of the internet. Still, Salt is used to get the results of these probes. One simple command probes those results. This one also is embedded in Salt. And we plot those results and look very worrying. This is how the internet looks like today. Packet loss everywhere. If you can see the timeline, some transits have sometimes packet loss 100% for a couple of hours. This is very sad. And using this system, this orchestrator of Salt, we are using it to generate the configs, to push the configs on the routers, and also retrieve to collect the probe results. We have an external service called the network that to get those probe results together with 5 to 2 errors plus interfaces load and many other layers from Prometheus and so on, intelligently takes the decision to disable some transits or anycast in some locations and sends back the request to Salt to disable anycast in some locations or a transit. And we only watch and enjoy now how Cogent is disabled in all Europe, or Comcast is able in all North America, or sometimes Anycast is able in locations like Medellin and so on. How often? Again, is very worrying because it says something about that. I just took a random window some time ago. It was like in October when I plotted this chart. And it shows about 120 config changes per day. That's a lot. Yeah, and this happens without any kind of human intervention as of today in our network. If you like these tools and you want to contribute, as I said, you don't need Python requirements. And we've seen, I guess, that I didn't type any line of code. But these tools has the meaning to help you make the very first steps. On the long term, is very good if you can, helping you to automate your tasks. You'll have more spare time and you can learn Python. And I encourage you to do so. And preferably to contribute back to the community. Everyone will appreciate that. Those two great projects, to Napalm and SolStack. If you have any questions and you need help or advice, join these two rooms, SolStack and Napalm, on Slack, or send me or my colleague Jérôme Fleury an email. Also at the end, I have a list of references with all the links you need to read. When you read all of this, you will be experts, and you will can do anything you want. Ooh, this one. Have any questions? You understood anything?
Just one quick question.
Sure.
At the very beginning, you said that there was no difference between holding one device or 1,000 devices.
Yes.
I guess that spools up parallel processes.
Yes, yes. Everything is in parallel. That's why.
Have you found that there's any sizing issues, the size of the system that you need to run this on, or it's extremely efficient at doing that?
So far, I didn't see, but it's equally true that I don't have such a big network. I mean, I guess many others in this room have much bigger networks, and they can test and bring me feedback. But on the server side, as I said, LinkedIn, they are running on 70,000 servers, and they do it pretty well. So the same methodologies, I guess, would fit also in the needs of networking. But It's just a supposition. I don't claim it will work on 70,000 routers. But for the moment, on our needs, it's scaled very well.
Thank you, and thank you from everybody in this room. I guess it's easier here, a quick announcement for everybody. For the social today, it's about a 10-minute walk, so you're on your own to get there. Please, if you're new, remember to bring your badge. It makes it a lot easier. You don't have to check off names if you see the badge. Thank you.
Sure.
I remember when you had the two entity servers in the list and then
Yes.
you removed one of them. So when you run it, it says like removed and this IP address.
Yes.
So when you did it recognize as well that if it's Cisco, if it's Juniper, there are different ways of doing like appending no and or like delete both of them?
Yes, this is because a couple of configuration parts have been standardized, and the templating has been moved in the library that manages the configuration underneath Napalm. But this is not for all configuration parts. Some templates cannot be really standardized because it's impossible to cover all possible needs in BGP, for example. It's so diverse, it would be a bit overkill to try to standardize them. But on the other side, you can use the cross-vendor templating system, and you can define them on your own, and you reference one single template to be run. Inside the template, as you've seen, we'll know to identify what configuration slices to deploy depending on the platform, vendor, and so on.
Yeah, but when you remove it from the line, does it also check if this configuration has already been in place?
Yes, yes. This is what the state does. It retrieves from the device the existing NDP servers and compares the lists. It doesn't compare, like in other frameworks, chunks of text. Because if they would be reordered, it would say is different, but they're not. So it compares the list of NDP PSO servers you have defined in the pillar with the list of entities that is defined on the device. And we'll compare them and we'll make the difference, what I have to add, what I have to remove.
Thank you.
How would you recommend introducing this into a production environment that already has a state? Can you download the existing state into the salt?
When we upgrade Salt, we'll take the states that do not exist in the previous versions. Or if you deploy your own state, you mean?
Yeah, I mean, I already have MX40s in production.
Oh,
I don't
cool.
want to break them.
Yeah, if you want a new state to not be in production, you want to have it in development mode, in the file routes, as we've seen, you can define the multiple environments. Probably now you have in prod or base. You can define a new environment, like develop, and add the file routes pointing to the directory where we have the new state. And then you run it without affecting anything else. And how to run it is something I haven't covered. It comes more on the development part. Is about extension modules. If you can keep in mind this keyword, extension modules, where you can put your states, and usually will be like underscore states. And this is the place where you put your custom.
Thank you.
Welcome.
Are you doing anything to account for a potential inconsistency with, for instance, when you ran that config on the Junos box, you said sometimes it takes a while to run, sometimes it times out. I work with another vendor where the XML TTY agent fails, maybe like once a week or so.
Yeah, sounds familiar.
Yes, and it has to be manually restarted. So do you do anything to account for something where either, let's say that process fails, or the state doesn't run the Juniper box, or how do you account for those kind of outside situations?
It will simply come back and will stay will failed. There are two fields to look into. If you remember, let me try to plug in again. Maybe it will work. Do Do you have 1 minute to try something?
Sure.
I will try something that definitely will fail. Let me try the other one. Will fail like that. There are two fields to look into. The comment will give you some details as much as the device returns back. The other field is result, which is set false in this case. So you can poll this flag and say if it was succeeded or not. And also you can have an addition when it fails. This traceback that gives you back all the details, and you can submit bugs and for the community. And so only and these two fields will tell you that the XML agent cracked or so. Yeah, I have experience with XML agent and I know how it looks like.
Thank you.
Okay. As a feedback from you, did I move too fast? Was it too fast? Did you manage to see what was going on? Did I switch too fast between windows? Unfortunately, ideally, this should be presented with one projector with slides and one with CLI, but unfortunately we don't have the meaning. And I had to do it myself, switch between them. Anyway, if you missed anything, you can, as you've seen, I followed exactly the slides. I just copy-paste between them, and you should be able to reproduce step by step what I've done today. If not, you can ask questions in the chat, so email.